Okay, so I want to start by giving you the first sort of chapter 0 lecture. So we're going to start with, chapter 0. And these are, remember, chapter 0 is going to be out of the chapter 0 file on the Stitz-Ziegler website. And so this is not, so Stitz hyphen Ziegler.com. So this is in the syllabus. Chapter 0 is a separate file from the pre-calculus textbook. So you're going to want to go and look at this, but we're going to start with section 0.1, which is set theory. So set theory is a bit abstract, and it's not really the focus of this course, but what we're going to review here is going to just make everything else go a little bit quicker. So your suggested exercises, that is your homework, are going to be exercises number 5, 9, 15, 19, 23, and 27. Again, you can find this in the notes. So if you look at the notes, we have right here, this is on the blackboard. This is what I've assigned for this section. And again, these are the exercises. So these are exercises. So you see here it says exercises. That's not to be confused with examples that they have worked out throughout. So that's different from examples. So I would ask you to go through these exercises on your own time, but I can, of course, answer questions about them in class. Now, the big things that I want you to do, and I'm not going to ask this for every section, but to start out, I would ask that you read the whole section. It's not so much that you're going to need to memorize every little word of this, but if you can read this whole section, then that's going to, not only will you have some of the material down, but that's going to build into your study schedule time to read these sections. So one of the big complaints that I get from students is, oh, well, I can't read textbooks, that it's not even written in English. And my response to that is, it is written in English, it's just a different form of English than you're used to reading. So if you're having trouble with a particularly difficult passage, then I'm happy to sit down with you. We can meet over Zoom and talk about it. But I want you to elevate your level of reading ability by reading through this section. And I'll have you read a few other subsequent sections. This isn't going to be for every single section, though. The main topics are going to be sets, elements, subsets, the empty set, union, intersection, and Venn diagrams. Again, if you can't read my handwriting or something, you'll have all of this typed out, but I'm writing it here so you can kind of see it in real time, because if you just look at a typed document, it's easy to say, yeah, I've heard of all that. But if we're going through this slowly, piece by piece, then hopefully this will make sense. I'm also going to go over interval notation and some special sets. This is N, it's the natural numbers, R, the real numbers, W, the whole numbers, which I won't use too often, Z, the integers, and Q, the rationals. And I'll just mention the complex numbers, but we're pretty much not going to be using the complex numbers in this class. I'll tangentially mention them, but I don't plan to get into the complex numbers much in this class. So I would ask that you work through examples 0.1.1 and 0.1.2. So we saw some of those as I was scrolling through the books. So let's start. So this is the basic outline for this section. And again, not every section in the review is going to be quite this in-depth, but since some people haven't had set theory, I'm going to go a little bit more slowly here. So I'm going to give you a relatively non-definition of a set. I'm going to say a set, and since I'm defining it, I'm putting it in a box, which is unfortunate because for the definition of set, it's kind of it's not really a good definition. But in general, this is how I teach. A set is a collection of objects called elements. Okay, so you notice that I'm defining two things at once. I'm defining elements as things that are in sets. I'm defining sets as things that contain elements, or that consist of elements. I'm somewhat appealing to your primitive notions of what the English words set and element mean. And I don't like to make a habit of this, but if we get really down to the details of set theory, it gets very complicated and ugly. And for anyone who's interested, I would recommend Googling set theory. You can spend some time in a Wikipedia hole, but I just want to give us some surface level knowledge so that we can use this in this class. So I'm going to do an example of using colon equals to define something. Now, I am a lazy speaker, so when I say example, I say example. So e.g., which is Latin for something, means I'm going to give an example. This is to be held in sharp contrast with exercises. So that would be EX if there was an exercise, like if I'm going over some exercises if someone has a question. So e.g. is example. Let's define something with a colon. So I'm going to say A is defined to be curly bracket 1, 2, 3. So this colon equals here, this is basically a bit stronger than an equal sign. So if I just say A happens to equal this set, that's one thing, but I'm telling you, here's this set 1, 2, 3, and I'm defining A to be that set. So whatever A was before, probably nothing, it's now this thing. Let's let E be the set. So E is the set of even numbers. Okay? So I'm just saying, let's call E the set of even numbers. And then I'll do another example, which is going to be using what we call set builder notation. I'm going to write B colon equals, and I'm going to say X such that, so there's another colon, but this colon means something different. If that's confusing, that's okay. I'm intentionally putting these two things together so that you're aware of them. I don't want you to think, oh yeah, I know what the colon means, and then see it in a different context and not be sure. X such that X is greater than 1. So this colon here is read such that, or occasionally we read it as for which. Whereas this colon is a definition. That is, I'm defining the set B. Okay, so to finish out this section, let's go through a few basic set operations, and then we'll look at some of these special sets, and that should basically do it for us. So this is section 0.1, continued. So let's look at some operations we can do on sets. So if I say, and this is stuff that I hope most of you have seen some of this before, maybe in a different context, but if I have two sets, then X union Y, this is X union Y, is going to be the set of all elements in X or in Y. Now this is tricky because, like I've underlined this or here, there's a potential for confusion here. If I say all elements in X or in Y, I mean if it's in X, it's in the union. If it's in Y, it's in the union. So hold that thought, and I'm going to define intersection here. So X intersect Y, we say X intersect Y. Oh, and this is a definition here. And this is all elements in X and in Y. Now the problem is, and I'm gonna intuitively jump into a Venn diagram here. If I've got, let's say, the following example, let's let A be the set of numbers 1 3, and 5. And let's let B be the set of numbers 3, 4, and 5. Then the union, A union B, is anything that is in A or in B. So 1 is in A, so 1 is in the union. 2 is in neither, so we can ignore 2. 3 is in A, it's also in B, so it's in at least one of them. 4 is not in A, but it is in B, so 4 is in the union. And 5 is in both, so it is in the union. Now let's look at A intersect B. So this is only the numbers that are in both, or only the elements that are in both. It just so happens these elements are numbers. So 3 is in both, and 5 is in both, and that's the end of the story. Why am I making such a big deal out of this? It's totally reasonable for someone speaking colloquially to say, well, what's A union B? Oh yeah, that's anything that's in A or anything that's in B. It's also totally reasonable for somebody to say, oh yeah, A union B, that's everything that's in A and B. Okay, so we have to be really careful with our use of the word and our use of the word or. Because when I say all elements in all elements in X and Y, I mean it has to be in this and it has to be in that. But you can imagine someone saying, well, what's the set of players on the field? It's the set of people on the first team and people on the second team, right? So just the way that we interpret the English word and when we're using this can be a little bit precarious or tricky. So I just want you to be careful there. I'm going to avoid any confusing language. I'm going to try to be very clear with things when I'm asking you questions or presenting examples, but I just want you to be aware of a potential point for confusion. So now let's jump into Venn diagrams. Like I said, so Venn diagrams are a handy way to illustrate these relationships. So Venn diagrams. So with a Venn diagram, and I'm just going to do A and B for now, and we can throw in C later. What I do is I draw a circle for everything that's in A, and I draw a circle for everything that's in B. And occasionally, I'm going to need to do a little bit more, which is everything that's not in A and that's not in B. And that little U there stands for universe. Sometimes we explicitly define the universe, sometimes we don't. Anyways, if I want to indicate A union B with a Venn diagram, I will shade the A circle and I will shade the B circle. Notice how we said union was or. Why did I say shade A and shade B? Again, I'm trying to point out it's possible for this to be sort of confusing. However, I would not shade things outside of either circle. A intersect B would be everything that's in A and B, which means only the elements that are in both. So here's me shading only the elements that are in both. So these are sort of the two key things to start with for Venn diagrams. Let's do some more complicated Venn diagrams. So let's just pretend we wanted to look at A intersect B, and then we'll take the union of that set with C. This is mathematics, so the parentheses work just like we'd imagine. Now if I have A, B, and C, I'm going to want to draw circles that have a large overlap. Notice where I'm starting my circles. I start in the middle of the previous overlap because that's going to give me a big overlap. So I've got A here, B here, C here. And if you've learned a different way to draw these, that's okay. I just want to caution you against what I see some students doing is they go like this, and then it's really hard. They've got these nice big circles, but it's really hard to see what's in the intersection here. So we want to try to have nice, big, healthy overlaps like this. So let's try to indicate A intersect B union C. So if you're watching this video, you might want to stop here and pause for a minute. I'll pause and take a sip of coffee. So what is this? Well, it's A intersect B we saw was a little football shape. Union C, so it's everything that's in this football or in C, which means I also need to shade C. Now I'm going to shade C a different direction here, but it's all four of these regions that are shaded here. Let's do a different example, and then I'll just do the special sets and then we'll finish. So let's do A union B, and then we'll intersect C. So again, start with these nice big overlaps, A, B, C. Okay, now, as I'm going about this, sometimes I might be working and realize that I need to go back. So let's take a second and try to do this. You can pause the video. Okay, so presumably you've paused the video or come up with some sort of a guess. So I'm going to start by just shading A union B, and I shade it one way. And then I want to shade C another way. Okay, just like before. But here's the thing. When I'm doing intersection is different from union in that for intersection, I want the things that are shaded both ways, which means my final answer, so this is my, this is just my work, and my final answer then is going to be the regions that are shaded both ways. Because for intersection, it has to be in the first shaded set and in the second shaded set. So we get this little mustache shape here is our final answer for this question. So you might want to say final answer. You might want to circle it. Whatever you want to do, somehow indicate if you've got multiple diagrams on your way to the answer, you want to indicate which one's your final answer. Okay, so the last thing that I want to do for this section 0.1 is I want to talk about these different special sets. So the natural numbers is going to be just the counting numbers starting at 1, 2, 3, ... and this goes on to infinity. Next, we have the real numbers, which is what most of us think of when we hear the word number just in a natural concept. So this is all, and I'm going to say numbers here. So including fractions, negatives, non-repeating, infinite decimals, or irrationals, all sorts of funny things. So this is kind of the whole set of any number you can imagine, but no square root of -1, right? We're gonna not have the square root of -1 in the real numbers. And I am having a really hard time just indicating -1 under the square root sign. I'm gonna make it nice and big. None of that. Okay, this leads to imaginary numbers. We're going to avoid those in this class. Okay, now the book is going to introduce this semi-common thing. So this is not super generally accepted, but this thing they call the whole numbers. Oh yeah, so I guess I should call this natural numbers. This is the real numbers. And this is what we call the whole numbers, which is just the natural numbers union 0. So it's 0, 1, 2, 3, ... This is what they call the whole numbers. I don't plan to use this terminology too much, but this is what the book uses, so I wanted to mention it. Then we have the integers. Now the integers are going to be like the natural numbers, but also they're negatives, and we throw in 0. So this is like ... -3, -2, -1, 0, 1, 2, 3, ... And this is the integers. The Z is for Zahlen, which is a German word for number. Okay, then we've finally got the rational numbers. So this is a Q, and this is the set of numbers, I'll just say rational numbers, rational numbers. This is the set of numbers that can be written P over Q for P and Q integers and Q not equal to 0. So notice I said that it can be written this way, so not that it must be written this way. A handy dandy thing you might see me doing, so if I wanted to communicate P and Q are integers, you might see me write P and Q, oops, I need to mind my P's and Q's. You might see me write something like P and Q are elements of the set integers. So this is a symbol which means element of. So I don't know that I'll be using that this particular symbol a lot in this class, but I figured I'd at least mention it in case I use it. So if you have any questions, of course, feel free to email me, and that concludes our lecture for section 0.